But for now, I'm gonna give the mic to Thibault, Simon, who's gonna share work with David again on BoaviztAPI and cloud providers and how to evaluate their impacts with an independent methodology. So, hi Thibault, I gave you the presentation, right?
Yeah, thank you. Okay. Hi,
can...
thank you, David and Letitia. And I guess you are now seeing my screen, I guess.
Yeah.
Okay, perfect. Thank you. So I'll try to be quick, so we finish on time. But this is a paper that we wrote together with members of Boavizta, notably David, Adrien, which are here, I guess also, Eric and Samuel, as well as Romain Rouvois, which is my PhD advisor, which is the man that make paper accepted. The idea was to try and publish the work that has been achieved on BoaviztAPI at an academic level in order to be criticized, but as well as internationalized and recognized by others. And the other idea of this paper was to be the base for possibly others paper, if we have the time, on other aspects of the work that we did, such as, for example, the GPU work that was conducted by Samuel. We wanted like base paper to refer to in order to simplify the things. Now, this one is only on BoaviztAPI. I'm gonna quickly switch the introduction slides, but basically the idea is that the problem we faced is that cloud providers reporting methodologies are hardly comparable with each other due to differences in boundaries or scope, differences in methodologies that are used, as well as reference data, making the output that we have in CO2, for example, hardly comparable with each other, and making the comparisons like not really meaningful. So what we wanted to have is an agnostic methodology, provider agnostic, which was then able to compare the data while being agnostic of the provider or the technology that is used. The second idea was that we want to have actionable levels. That is, we need to be able to pinpoint which point of our system have the most impact in order to, at the end, reduce this impact. So you will see at the end the kind of output that we want. So in order to obtain actionable levels, what we did is to obtain a bottom-up methodologies where we start from the components in order to model servers. This is what you know. This is BoaviztAPI currently, but this was what we wanted to publish at the beginning, but we went a bit further than that, and the next step was to model what we call cloud platform, basically an infrastructure, physical infrastructure, and in order to do so, what we added was what we call the technical environment. This is basically the building, the data center, as well as the PUE. We'll talk about this later. And then what we then subsequently do is that we, once we have this cloud platform that is constituted of multiple servers, the technical environment, what we do is that we want to allocate each resources available on this cloud platform to the different cloud instances. Basically, see virtual machines or containers or what you want. Basically, a virtual component. So from the beginning, let's go to the component. This is what you probably know. This is the formulas from BoaviztAPI. They are a little bit updated in the paper because what we define here is what we call an impact factor. So we have to divide by the D, which is the life expectancy, in order to obtain an embedded per hour, basically. You probably know the formulas, or if you don't, you can go in the paper. But basically, we have two formulas for each component. We study the embodied footprint, which is coming from the manufacturing, mineral extraction, transport, etc., etc., and also the usage footprint, which mainly stems from energy consumption and the impact associated with this energy. Going up a level, basically, we go to servers, we aggregate all these components. We already talked about this, but if we go one level up again, we have the cloud platform. So to form this cloud platform, we have to add the technical environment. And as we studied the embodied as well as the usage footprint, we want to have both these aspects on the technical environment. For the usage part, it's kind of easy. You have to consider the PUE in order to get the energy that is associated with this. But for the embodied part, which is the building of the manufacturing of the data center building, for example, you also have to consider this. So in the paper, this is work done by Eric and Pierre, mainly, we provide impact factors in order to assess this embodied footprint of the technical environment on the three impact categories that are covered by BoaviztAPI. And now we have our cloud platform, and what we want to do is to allocate to the cloud instance. So for example, if I want to have virtual machines with 4 vCPU and 10 gigabytes of RAM, for example, what we do is that for each of the resources that we covered, which are CPU, RAM, SSD, and others, which is the motherboard, the fans, etc., which is allocated based on the CPU. But for example, if we take the CPU, what we are going to do is that we are going to count the amount of CPU that is in our cloud platform. Let's say 10, for example. And if my cloud instance uses 4 of these CPUs, I will have 4 out of 10 that is associated with these CPUs. And using this on all the categories we have, we can obtain data such as this, which allows us to assess the cloud instance impact stemming from the different components, which is a benefit from bottom-up approaches. But what we are able to show is for example, if you take the usage, that most of the usage footprint comes from the CPU, which is expected, and then you can see that we used, if I remember correctly, a PUE of 1.5, so we will have a third of the impact that come from the environment on the usage, which is right here. But now, if you look at the embodied footprint, you can see that the environment from the factors that we propose in the paper also have quite a lot of impact on the final instance footprint, as well as other things. And the idea here is, compared to like more traditional approaches, is to be able to tailor this compared to the component that you really use. For example, if you here you can see that storage footprint is quite low because we don't really use here a lot of storage. But if you consider, for example, a storage instance which is used for backups or things like that, then you will see that the embodied footprint would be quite larger. And this is the kind of thing that you can see thanks to bottom-up approaches. Now, to conclude quickly, what we defined in this paper is a bottom-up approach to find actionable levers, as I explained a bit. The idea is not only to consider the energy consumption or the use phase, but the life cycle of resources. This is embodied over the 3 categories that are covered in BoaviztAPI. All of this is done as other things in Boavizta using open source methodology based on open source data. And as future work, we have multiple things that we can do if we have time, which is basically add notably the GPU work that has been done notably by Samuel. But also there are things that we can add, such as the infrastructure overhead, because we are accounting for multiple things, which is that the infrastructure is used fully, and there is no ratio saying that resources can be not used in real life, meaning that the used virtual machines impact will be larger than what we account. You can also improve the time-based allocation, and finally we can better handle uncertainties, which is something I would like to do, but I don't have the time in the BoaviztAPI. And this is not for you, but basically, yeah, the idea was to publish in the academic world. It was kind of well received, so it's a good first step. And yeah, that's all I wanted to say, I guess. So yes, no, the thing that I wanted to precise is that I guess David told this in the chat, but this approach that you can see here is not yet implemented in the BoaviztAPI, including the technical environment, due to time and implementation constraints in the API. So if it's going to be a future work also. So yeah, thank you for your attention, and if you have any question, please ask. So
I think we should definitely talk, because we've I really completely agree with the approach you take with the methodology. We've extended it to include things like networking as well, and we've defined networking in it's quite granular definition within regions, between regions, and external. We've looked at network and local storage. We're currently grappling with serverless as well. So how do you begin to look at the impact of more modern infrastructure when it's not all instance based? I know you mentioned kind of containers and stuff, but there's other things that are going on. So it's a really interesting area. One of the things that we're continually grappling with is the quality of the data of the input into the algorithm. So you mentioned PUE. I think you're using a PUE of, what was it, 1.5?
Yeah, in this approach or in the paper, yeah, we use 1.5. But
you know, it's too high for like AWS. Yeah, AWS, their global PUE is like 1.22, I think. But we know that many of the data centers run far lower. So is that also how do we ensure data quality given that we don't have the data? It's a really interesting problem. So basically, I think we'd love to kind of collaborate more on this.
Yeah, for the PUE, it's like as I explained a bit, this is a model, so you can just change the parameters. And for example, the PUE we use here is like because we wanted to show this, but yeah, if you update the PUE, the PUE, you will have different data. You can lower it, but you can
also not believe the PUE numbers from AWS.
Yeah.
Anyone from AWS on the call? But no, really interesting. Thank you.
Thank you. I guess Laurent or Lauren, sorry, I don't know, you have a question?
You mean Laurent?
I didn't mean Laurent, but it can mean Laurent.
No, well, I just put a question in the chat because I read your paper and it was very interesting. And the only thing that wasn't clear for me was how the technical environment was computed. Well, I know that's Eric who's worked on that and he's my colleague, so I'm going to ask him. But maybe, I don't know if you've got a focus on that, or maybe it would be interesting for him to present that in the next meeting.
Yeah, I guess it could be nice for him to present it because honestly, this is Eric's magic, and I don't know how he did it. So.
Okay, so I'm gonna ask him because I'm sure people will be interested in that part.
Yeah, I guess it's not that complicated, but yeah.
Yeah, but I know he's worked a lot with ADEMARCEP studies, and he's very well skilled with those data.
Yeah.
Are there any other questions or comments about the study?
We would like to. We don't have time, Thibault and I, but we really would like to take the time to update the API, which mean also have some architectural consideration. I know there is a hackathon, but last hackathon was not very conclusive for this. So yeah, I don't really know how to do it, but if anyone who have a competency in development want to join the team and maybe get more involved in this project, this might be code refactoring. It might be nice. Maybe on the next hackathon, if you are available, we could do a team where new people that want to give time to the API come, and then we work about code refactoring together. It's pretty fun.